math. You're a little scared. Don't be afraid, I'm right over here. Don't be ashamed, you're a little lost, 'cause we all get it that way. Well, welcome to another edition of Math Teacher to Go. I hope you're not a little lost, but just in case you are, that's okay. Okay, the chain rule with more complex function. What students tend to like least about the chain rule is you can put functions inside of functions inside of functions inside of functions, and nobody can get in touch with their inner function anymore. So, sometimes we have a hard time knowing when to stop. When have I applied the chain rule for the last time? What's my last chain rule kicker? So I'm going to try to sort some of that out with some examples here. Let's take the kind of classic trig function example, sine cubed of e to the 5x squared. It's helpful when you have a trig function raised to a power to rewrite it first. Remember, the 3 on top of the n of the sine means that you're cubing a sine. A whole sine function gets cubed. Now, if you can see this, the cubing is the last thing you would do. If you had a number for x, you would square it, multiply it by 5, make it the exponent on an e, take the sign of that, and then cube the final result, cube to get the final result. So the first thing you're going to do is deal with the cubed. So here you get the x gets squared, multiplied by 5, that becomes a power of e, that becomes the argument of sine, and then the result is cubed. For the chain rule, to take derivatives of your function, you work from the bottom up. The first thing you have to do is take the derivative of something cubed. The rule for taking the derivative of something cubed is you do 3 times the something squared. You don't change the something. So there's your 3. If you look here, I've got the 3 right there. Sine e to the 5x squared, that's the same. So I get the 3 out in front, and I've reduced the exponent by 1. And this right here, this d dx sine e to the 5x squared, just reminds me that I still have to multiply it by the derivative of what was inside the thing that was cubed. So now this first part of my derivative is done, so I write it again. And now I look at the next piece. If you look up our list here, after you cubed, working backwards, sine was next on the way up the list. The derivative of sine is cosine. The derivative of the sine of something is the cosine of the same something. So I do cosine of e to the 5x squared, because that's what I had the sine of. Now I still need to multiply that by the derivative of the stuff that was in the argument of the cosine. So I just put this d dx of that to remind me there. But now I've got the 3 sine e to the 5x squared, that whole thing squared, times e to the 5 cosine of e to the 5x squared. And I just have I have another chain rule piece to figure out now. So if you're working your way back up this list, you made something a power of e. So when you take the derivative of e to a power, you simply write down e to the same power. Here's the 3 times the sine of something squared times cosine of something times e to the 5x squared, which is the derivative of e to the 5x squared, times its chain rule kicker, which is 10x, because we also have the 5x squared piece there. I guess I skipped a step. Here is the derivative of the e, and then I still had to deal with the fact that the exponent on the e was a function, so I dealt with it down here. 5x squared is a derivative of 10x. This whole thing is the answer to what was the derivative of sine of e to the 5x squared quantity cubed. The issue is becomes as much a bookkeeping issue as a calculus problem. You don't know when you're done. I find it helpful to go back to the original problem, and after I take care of the cube part, I do the cube times sine to the something squared, I cross off the cube, and I work my way inward. You could write out this whole list. That might be a way to start. That might help you. But I cross off the cube, and then I see, okay, the next thing I see working my way from the outside in, which is the opposite of what we do in order of operations. Next thing I see is sine. When I write the word cosine of e to the 5x squared, I cross out sine. Then I say, okay, the next thing is e to the 5x squared. I write e to the 5x squared because that's the derivative of e to the 5x squared, or the beginning of it. I cross off the e. That leaves me with the 5x squared. The derivative of 5x squared is 10x. And I cross off the 5x squared. I've taken the derivative of each and every operation. I will show you that on the board next time I see you if I haven't already. Okay, that's it for Chain Rule Part 4. And I hope you have a good evening.